Shall we start?
Yes, okay, sir.
Okay, sir.
Okay, sir.
Okay. So we were discussing this presentation, time value of money. We discuss indeed what is the interest, what are the components of an interest rate, and simple interest and compound interest. Those are the things we discussed last week. Any questions up to that point? Any question? Clear? So let's see. Now can you see the board? Is it visible, please? Can you all see the board, please?
Yes, sir.
Yes, sir.
Assume principal value is 1 million. Interest rate is 8%. And number of years 5. What is the interest either you pay or you receive? Can you do the calculation and let me know the answer?
Is it a compound interest or a simple
Yes.
interest?
Compounding.
$469,328.07.
400.
69,000
69,000.
328
300.
.07 or 08.
08. Is it correct? Others, is there any other answers? Different answers? Any other answers? So there are about 40 participants. So I heard only one person's voice. Others, are you in agreement with this answer or not? Then the answer is correct. So then I hope you know how to get that. So I'll move forward. Before I start the today's session, the continuation of this. Again, I would like to remind you what I already told you. There will be a lot of questions like this, calculations. I will ask a lot of questions from you. Please respond. Don't wait for someone else to answer. If you have questions, please ask questions. And the most important thing, these calculations that you have to do it by yourself. Don't wait until I do it here. And after the exam and once the results is released, don't call me or IBSL staff saying, so I did the exam well, but I couldn't go through, things like that. Because there's no point of asking those questions at the end. How do you know whether you did it well? Only thing is, when you do the things in the classroom, you should try and learn things and see whether you have done it correctly or not. And otherwise, you think your answer is correct, but it may not be the correct answer. So whenever I ask questions, try to answer, give you an answer, then we can discuss whether it's correct or not. If it is not wrong, what are the things that you did incorrectly. So I would like to remind that again, please participate. Don't be passive in this. class. It's not good for you. Be active, ask questions, try to answer questions. If you don't get that answer, don't hesitate, ask. I didn't get this answer. This is the way how I did solve that problem, or try to answer that question. What is wrong? Then only you can get the clarification, or the way what is wrong, the way that you think, or the approach to the question. Or you may completely try to understood the question in a different manner. All those things can happen. Yes, we just released last year results. When I do marking, I saw that sort of answers. The question is asked, say, foreign exchange. Someone is trying to answer is in interest rates side. So that means you cannot understand the subject area. What is the topic? That can happen if you don't participate in the class and discussion. You just listening, it won't help you. That's a message that I have to pass. Don't wait until the end and it will be too late. Don't think you can capture or grab this thing by attending a one revision class or things like that. Towards the end, we'll have a one revision class, probably, and a paper discussion, past paper discussion as well. Again, my advice, don't try to answer only few or get ready with targeted questions. It may not work. Try to understand the whole syllabus, whatever the learning outcomes required. That is the best way. So that's again my advice. During the class, if you have any questions, please ask, don't hesitate. There's no problem. But after the exam, once the results released, calling or texting me or IBSL staff, it won't help you. Be active now, not after the exam. So with that, even last week, I wrote an equation on the board. You can remember that. Future value equals present value times 1 plus R N. Then, can you see the board?
Yes, sir.
Yes, sir.
Yes.
Yes, we can see.
Keep it to make sure. Okay. So then I mentioned that N is the number of periods, not the number of years. And I mentioned there's a reason why I didn't mention it is number of years. The thing is compounding. But the two examples we did today, the exercise for you, and the example we did last week, the compounding frequency is year. That means we assume every year interest income will be reinvested for the rest of the life of the transaction. So compounding frequency is annual. But there can be situation compounding frequency can be, if you need, it can be daily or week. So most common things are monthly and quarterly or semi annual. Any of these can happen. There's another one. I'm not going to discuss that. So that can be continuous. So that means every moment it is compounding, but I'm not going to discuss this with you. I don't want to bring too much mathematics into the picture. So compounding frequency mostly can be any of these other than this yearly or annual compound. So therefore, depending on the frequency, number of periods may change. That's why in this equation, I didn't define this n as number of years, but number of periods. So what's the difference? If the previous example or the exercise I given to you, I mentioned number of years. Fine. But if I tell you compounding frequency is semi-annual, what would be the answer? What does it mean? What does it mean compounding frequency is semi-annual?
Interest paid in every 6 months.
Sorry?
Interest paid in every 6 months.
Interest is calculated for every 6 months and added that interest component to the principal. Yes. Okay, first of all, let me know if I write something here, you can see.
Yes.
Yes, sir.
Can you see this?
Yes, sir.
Yes.
Here. And on the other side, correct. You can see that this point as well.
Yes, sir.
So A equals 0, assume today. Then A equals 6 months, 4.5 years. 1 year, 1.5 years, 2 years, likewise. We can break the timeline into 6 month periods. What do you do? Our principal amount is 1 million. Interest is 8%. Then what do? We calculate the interest for the first 6 months. How do you calculate? 1 million into 8% divided by 100 divided by half. What's the interest component that you get? $40,000, correct?
Yes.
So then, what is the principal for the next 6 month period? This 1 million plus the interest component. So 1 million and 40,000 is the principal amount applicable for the next half month period. Then we calculate the next half month interest on this amount. What is that? $41,600. Then we add this 41,600 to the principal amount at the beginning of that period. That will be the principal amount at the end of the 1 year. Then you calculate the interest for the next 6 months. Likewise, you do this how many periods?
10 periods.
Sorry, 10 periods. Yes, because within a 5-year period, there are 10 semi-annual periods. Or there are 10 6-month periods. When we try to use this equation, instead of n, we have to use, instead of number of years, we have to use number of periods. Not only that, then we have to be careful about this interest rate as well. Because you can see, even though the interest rate is 8%, we divide it by 2 to get the semi-annual interest rate. Therefore, when you do this calculation, future value equals present value into 1 plus R over N. This R also adjusted interest rate. You adjust for what? Adjust for the frequency. To solve this equation, principal value limit is 1 million. Then interest rate, quoted interest rate is 8%. That's fine. But you divide it by 2. And there are 10 semi-annual periods. Therefore, this n equals 10. use the calculator, you will get the future value. The difference between future value and the present value, today's principal amount is 1 million, is the interest amount. Is it clear? The key thing that you have to remember is adjusting the interest rate and the number of periods. So this is very important, not only in this, even in future classes or topics that we are going to discuss. You may remember the equation. Fp equals PV times 1 plus R to the power n. You can remember this equation and write it down. But the problem comes when you are going to apply this equation. If you don't know what is R, you don't know what is N, then it becomes a problem. So whenever you are trying to remember an equation, you know not only the equation, but what is the meaning of this? Someone can write this equation in a different notation, but the concept or the definition should be the same. That's the key that you have to remember. If you have to remember equations, formulas, you should know what are the definitions of each and every term and how to use it. Interest rate is 8%. If you write it as 8 without dividing by 100, it's wrong. Because this should be in the decimal form. That is another thing that you have to be careful when you use this equation. Whenever there's a percentage, you have to apply that in a decimal form in the equation. But there are some equations, we just ignore the percentage, we use the 8% or 5%, the full figure as it is. So you should be able to remember those things as well. Oh, the easiest way not remembering it, get the concept behind the equation. Then there won't be any confusion. Okay, any question? Any questions? Is it clear? Then shall I erase the board? Assume present value for the principal amount is 500,000. Interest rate 10%. Number of years 6 years, and interest compounded frequency is quarterly. What is the future value and what is the interest amount? Can you calculate it?
Future value is 362.97.
Sorry, I didn't get that. Future value is
904,000.
904,000.
4,000. 362.
4,362.
362.97.
Mhm.
It means the interest is 404,362.97.
Others, have you got the same?
Yes, same answer.
Same answer.
Same answer.
500,000, 10%, 6 years. Others got the same answer. Yes, the answer is correct. That's the answer. Any questions? Any questions? If not, we'll move forward. So this slide explain that the concept, there can be different compounding frequencies. It's not only annual compounding, it can be any other, it can be weekly. There can be custom non-standard products like that. But in the market, mostly used semi-annual, quarterly, and monthly. Very rarely there can be daily compounding as well. So this is the example given in the presentation. It says 10,000 rupees. You invest 10,000 rupees and interest rate of 4% annually. Pays every 6 months for 1 year. Suppose also that the interest earned at the end of the first 6 months can be reinvested for the remainder of the 1 year in investment period. That means at the end of the first month, you get interest. You invest that interest amount for another 6 month period for the remaining maturity period of the transaction. Then at the end, you get, at the end of the 1 year period, you get the principal plus the interest amount. So asking you to calculate the interest amount that you earn. So to calculate the interest only, you can use this equation. But remember, you should be able to identify what is this. This is the this part is the future value component, and this is again the principal. The difference is the interest. So you can use it. If you can remember in this form, it would be better, because then you know that the interest rate has to be adjusted for the frequency and the number of terms as well. You can try this and see whether you get this number. Can you try and confirm me that you get the same number? Have you got the same number, this answer?
Yes, got the same number.
Okay. So shall we move forward?
Okay, sir.
So then how do we calculate the effective annual rate? What does it mean by effective annual rate? to do that, we'll do another exercise. Say, if you go back to the previous example, principal amount is 10,000. Interest rate is 4%. So, what would be the interest at the end of the 1 year period if there's no compound? So that means your investment for a 1 year period and compounding if the frequency is 1, that means annual, or you can say no compounding, simple interest, because it's only for 1 year period. On the other hand, same numbers, but compounding semi-annual. What would be the interest at the end of the first year? Now, you know these numbers. 1,268.25. What is the answer here? If it is 1 year investment without no compounding, that means you invest it for the 1 year period and interest calculate only at the, or payment made at only at the end of the 1 year period. What is the interest that you receive? Will it be more than this or less than this, or would be the same as this?
Less than.
What is the interest that you get at the end of the year, assuming interest is paid and
400 rupees.
sorry,
400.
I cannot hear you.
400 rupees.
200 rupees,
400.
300.
400, sir.
400 rupees.
400 rupees. Is it correct? Is this correct?
Yes.
Yes. How do you get this? 10,000 into 4%. That's it. To get 400 rupees. But then should be something wrong here. Is it the 1,250? Is it the interest only? Sorry.
It should be for 3 years.
It's for 3 years. That's the problem. Okay. Then we'll do that calculation as well, only for a 1 year. Compounding semi-annually, and even in the example of frequency of semi-annual, is what So if you do this, what is the interest?
404.
400.
4.
How do you get it? 10,000 rupees into 1 plus into. Is it correct? Principal amount 10,000, interest rate is 4%, but the frequency is semi-annual, so you have to divide it by 2 to the power 2. There are 2 semi-annual periods in a single year. So you get 404. Now, if you increase this compounding frequency from semi-annual to quarterly, what would happen to this interest amount?
Increase.
You divide this by 4 and increase this to 4. It will increase. So that's a relationship that you have to remember. When the compounded frequency increases, interest amount increases, or therefore the future value also increases. That's one thing. Okay, now even though you can see, even though the interest rate is set as 4% in both instances, actual income is different, 400 and 404. So in this case, if you calculate an interest rate again, using the interest amount that you receive and the amount you invested, you receive 400 rupees for 10,000. You would get 4% as the interest. But here, for the year, effectively, you get 404 rupees for a 10,000 investment. To make it a percentage, multiplied by 100. So you get 4.04. That is we call effective interest rate. Even though the quarter rate is 4%, effectively you earn 4.04% with the semi-annual compound. With the quarterly compounding, it may be more than that. Is it clear? What does it mean by effective interest rate or effective annual rate? Is it clear? What is this effective annual rate? The equation given in the presentation that you can use to calculate the effective annual rate without doing all these calculations, which we did on the board. Without doing that, you can use the equation straight away. But again, remember the same terms are appearing there. RST is the stated interest rate. M is the number of compounded periods per year. We don't want the principal amount in this calculation because it depends only on the interest rate or the stated interest rate and the compounding frequency. So Now you should be able to calculate what would be the effective interest rate for the same 4% stated interest rate. What if the compounding frequency is 40? What is the effective interest rate? Effective annual rate. What's the equation? Effective annual rate equals 1 plus RS over M with M minus 1. What is RS here? Stated interest rate is 4%. Compounding frequency is 4. So to substitute here, you get the answer. Can you work out and tell me what's the answer? Again, remember RS, it should be 4%. So therefore 4 divided by 100 and divided by 4 to the power 4 minus 1. You may get confused what are these 4. This goes here. And the frequency M, this goes. And the same thing. What's the answer?
Four point zero six
4.06.
six.
Others? Have you got the same answer, 4.06? Or do you have any other answers? Point 0.06. The answer is correct. Any questions? Okay, now let me know. Have you come across this type of situations, problems in your day-to-day operations? Yes or no? Have you? Or how do you use this knowledge? In your day-to-day life to make decisions? Let me ask a question. A bank in Sri Lanka owns the following. Say for fixed deposits, 6 month fixed deposit interest rate is 8%. 1 year interest rate deposit rate is 1.15. You want to make a deposit. Would you place a 8-month deposit or a 1 year deposit? Assume you don't want money in 6 months time. If you want, you can invest for a 1 year period. What is your decision?
Six months deposit, sir.
Why?
Because effective annual rate becomes 8.16 after the calculation.
Calculate the effective annual rate. It would become 8.16. Is it correct? The first thing, is it correct? Others, are you in agreement with him?
It's correct, sir.
Okay. So, if this is correct, you should go for a 6-month deposit. What are the other assumptions that you make? Because this is only for a 6-month period, and this is for a 1 year. If you just calculate the effective annual rate, is 8.16. It's true, correct. In that sense, it is better than investing in 1 year deposit straight away. Why? You think you invest or you place the 6-month deposit for place the 6-month deposit at 8%, and on the maturity date, you roll over the same deposit for another 6-month period at the same rate. Then at the end of the 1 year period, you get effectively 8.16. So what are the assumptions? So what is your view?
First assumption should be there won't be an interest rate change, reduce of the interest rate. If not, 8% is good, because if the rate's going down, you have a fixed rate for 8% for the 1 year.
Sorry, I don't know how it's automatically muted. Okay, yes, the explanation is correct, because you can earn 8.16 only if, so you invest for a 6 month at 8%. And at the end of the 6 month period, you reinvest the deposit proceeds at the 8% for another 6 month period, then you effectively get 8.16. So therefore, if you can do this, it is better than investing in a 1 year deposit. But the problem is, you don't know what would happen after the 6 month period. If interest rate has gone down by this, the 6 month deposits for the next period may be 7.75, something like this. Then you want to earn this 8.15. But if it has gone up 8.10, you are better off. So there's a risk when you do this transaction. If the interest rate goes down in the future, you may not be able to earn this interest rate. So therefore, the making decision, it's not only numbers. That depends on your view about the future. Here, is it clear? Any question? So this is a comparison. What would happen to the future value if you increase the compounding frequency? So the stated interest rate is 8%. That will mean you invest 1 rupee or $1. So if you invest 1 rupee at 8%, at the end of the period, 1 year period, you get 1.08. But if it is semi-annual period, you get 1.0816. So if you calculate EAR here, what is the EAR? This is 8%. This one, (8.16%). When it comes to quarterly compounding, 8.24%. Monthly compounding, 8.3%. Daily compounding, 3%. So you can see when the frequency increases, effective annual rate also increases. So in this effective annual rate calculation, the frequency, compounding frequencies less than 1 year, and we calculated the effective annual rate. But in this compound interest rate calculation, what we are going to see is, if you make an investment or a borrowing for more than 1 year period or for number of years with different compounding frequency, what is the compound interest rate? So almost same thing, you can see R divided by M, and here M into N. M is the number of compounding frequency or number of periods, compounding periods per year. N is the number of years. If I put this into numbers, what does it mean? Say, we did a calculation, 1 million at 8% for 5 years. Is it correct? The very first one we did. Can someone tell me what were the numbers? The very first example we did, 1 million
At 8%.
interest rate,
8%.
8%, and the number of years, 5. But in that we use annual compounding. Then it's not, we will go for the second one, 500,000. $500,000 interest rate 10%,
Number of years 6.
number of years 6,
Frequency is quarterly.
frequency is quarterly. Okay. If we substitute these, indeed we need only these 3 figures into this equation. What do we get? And what was the future value answer that we got? 904,362, something like that.
It's 362.
0.97.
362.997.
97.
Okay. So do the calculation and compare it with this figure. What's the answer you got? You get here something 0.8. 0, 8, 7, 3. Correct? Did you get this answer?
Yes.
So you get the same if you divide this interest component 404,362.97 by 500,000. So it's almost 80% of the principal. The interest component is almost 80% of the principal. If you divide it by 6, you get something 13 point, almost 13 point. Even though the stated interest is 10%, if you are to write simple and interest terms, it's around 13.5. So if you know the compound interest and you want to switch to stated interest, you can use this equation, or you can use the same thing to do other way around. You know this. Yes. This one gives you, if you know the stated interest, how to get the compound interest. You can use this equation to calculate the stated interest if the compound interest is known. However, I'm not going to focus this that much because we may not practically face this type of equations. This equation gives you how to do that, how to convert, say, two different compounding periods. Say semi-annual one to quarterly. What would be the stated interest rate? One way you can compare these two interest rates is to calculate the effective annual rate and compare. Or other way is without doing the effective annual rate for both, calculate the equivalent compounding or stated interest rate, change in the compounding frequency. It's like this, say, my example here, 6 month 8%, and 1 year 8.15. If you want to calculate the 1 year stated interest rate from the 6-month stated interest rate, you can use this equation. But in this example, you will effectively get the effective annual rate. However, you can use this equation to do that. Okay, we'll put some numbers and do it. Mark, can you see the presentation?
No, sir.
Partly. This is 7.9%. If you want to calculate what is the equivalent 6-month rate, then you can use that equation. I mean, this equation. You can use this equation. R2 equals 1 plus R1 over M1 minus 1 into M2. You can use this equation, say partly 7.9% interest rate. If you want to convert it to what would be the then 6-month interest rate, you can use this. But the thing is, now you have to identify what is R2, what is R1, and what is M1, what is M2. So you want to convert this quarterly interest rate to a 6-month interest rate. Then what is R1? R1 is 7.9%. This is what we are going to calculate. Then what is M1? M1 is part. So M1 is 4. M2 is the semi-annual. Then M2 equals 2. So substitute these figures. 1 plus R1 7.9% divided by M1 4 divided by 100 to make it a percentage. M1 4 divided by 2 minus 1 into. So you would get an answer slightly above 7.9. It may be above 8% or less than 8%. Based on that, you can take the decision with your view as well. What is the answer? What's the answer you get? Can someone tell me what is the answer?
Is it 7.97, sir?
7.97.
Yes.
Others? Any other answers? Have you got the same answer? 7.9.
97.
Okay, if you assume interest rate won't change in the future, will you go for a quarterly, frequency, or a 6 month? What does this mean? What does it mean? 7.97. So with this figure, I can say for sure, if you calculate the effective annual rate with the 7.9 stated rate quarterly, it would be less than 8.16. So what does this 7.97 mean? The semi-annual equivalent or 6-month equivalent of this stated rate quarterly rate 7.9 is 7.97. So if you roll over 2 times this investment, you invest a principal amount today and you get the interest at the end of the first quarter. You invest that principal and the interest for the second quarter at the same rate. At the end of 6-month period, you earn only 7.97%. But whereas in a 6-month deposit or 6-month investment, you could have earned 8%. So that's the meaning of this figure. Or on the other hand, you could have converted this 8-month and find it is equivalent of quarterly rate. Your answer should be more than 7.9% with these given numbers. Is it clear? If you calculate this effective annual rate for 7.9, you would get something below 8.16. Definitely it cannot be above 8.16 in this answer because this is below 8%. So with these equations, you can compare various interest rates. That depends on your requirement, whether you want to calculate the effective annual rate and compare effective annual rates or convert it to another equivalent frequency and calculate the rate. Any questions? Can you see the presentation?
No, sir.
Any questions? Is it clear what we did here?
So a small thing, what is the difference between EAR and AER? The banks use AER.
Same thing. So you use the different word, annual effective rate or effective annual. Same thing, no? This is just the jargon. However, what does it mean? What is the interest rate effective for a full 1 year period?
So excuse me, sir. In this
Yes.
equation, R1 and R2 is given here. The definition.
No, R2 is not given here. R1 is given.
Is given. Stated interest rate with compounding frequency of M2. Can you please tell me what definition for M1 and M2?
M1 is, say, now what we are going to do, say, in my example, okay, you are given stated interest rate for a quarterly compounding. Okay, you are given the stated interest rate for quarterly compounding. Then it's quarterly compounding. Then the frequency is 4. That would become M1. The stated interest rate becomes R1. What you are trying to do is, using that, you are trying to get what would be the equivalent stated interest rate for a semi-annual period. What would be, if the quarterly interest rate is 7.9, what would be the equivalent stated interest rate for semi-annual period? Then M2 becomes 2, because the semi-annual means frequency is 2, and the R2 is the equivalent stated interest rate. When we do the calculation, it becomes as 7.97. So for a 7.9% quarterly stated rate, the equivalent for the semi-annual should be 7.97. But in the actual market, it is quoted as 8%. Is it clear now?
Yes, sir. So in that case, for this, in this equation, we are considering both the frequencies, quarterly and
Yes, you convert from one frequency to another frequency. So in that sense, M1 should be the frequency now
4.
you have.
Yes.
What is the frequency that you are going to get is M2. The same thing is for R1 and R2. So if you are going from 6 months to quarterly, R1 would be the 6-month interest rate, M1 would be 2. Now you are moving from 6 months to quarterly, so therefore M1 to R
is 4.
is R1 is the 6-month interest rate. In this example, 8%. Then R2 is the what would be the equivalent interest rate in quarterly basis, and M2 would be 4. Clear?
Yes, sir.
Anything else? If not, shall I move forward? Then we are moving into the terms future value and present value. Even though I used these terms previously, this is the place where formally enters into that section. Present value, you can consider it as what is the value of an investment or a borrowing or whatever consideration value as at time equals to 0, as at today. Is it clear? What is present value? Present means today. What is the value of the investment or the borrowing as at now. Then with the applicable interest rate for a future period, at the end of that period, what would be the value of that investment? That is we called future value. So on the other hand, you can think it as what is the value that you are going to receive in the future if you make an investment equivalent to the present value at the rate of interest rate or the rate of return given. That is the future value. Again, that depends on the number of compounding periods. Here, it's not the compounding frequency, compounding periods. If we go back to our previous example, 5 years, semi-annual, then the compounding period equals to 10. If it was quarterly for a 5-year period, compounding periods would be 20, because in a 5-year period there are 20 quarters. Likewise, so this is very important, and R again should be adjusted for the period. So I think now you are clear about this equation as we did an example earlier. So the difference between future value and present value comes through this factor. And you can use this equation only to calculate a future value of a one cash flow. What is the cash flow today? Either you take it or give it. What would be the future value? If you take it today, in the future, you have to give it. If you give it today, in the future, you will receive it. We call this the future value factor. What are the consequences? What does it mean? We can add amounts of money only if they are indexed at the same time. What does it mean? Say, the meaning of that statement is, say you invest 100,000 rupees today and you invest another 100,000 rupees in 6-month period, then you cannot add that 100,000 plus 100,000 and say 200,000 invested, which is not correct, because 100,000 today is not same as the 100,000 in 6 months time. So therefore, the amounts appears in 2 different time frames. You cannot add them together as it is. You have to do some adjustment for the time value of money. Is it clear? Is it clear what this statement is? Basically you cannot just simply add the amounts in different time frames. Theoretically, you cannot add the money spent or you invest today and what you invest tomorrow as it is. You can't do that. Either you have to calculate the future value of your investment today for tomorrow, and add that value to the new investment amount tomorrow. You can't add 100,000 today and 100,000 or say another 50,000 tomorrow and say 150,000. You have to make an adjustment. Either you take the present value to the future or future value to the present. That's the meaning of this statement. And the second one that we experience this for the same interest rate, if the number of periods increases, future value increases. Say for 10 years, if you invest only for a 1 year period, what you get is less than if you invest it for a 2 year period for the same interest. I think it is clear for you. Is it, or you have any doubts? Is it clear? You have to tell me whether it's clear or not. For me, it's clear. If not, we'll move forward. Then we do adjustment to this equation to accommodate different frequencies to make it clear for you. So then instead of R, we use RS divided by M, and instead of just N, M into N. In that case, N is the number of years, M is the number of or the frequency of compound. So we did some examples. So therefore, I think we don't have to do any examples. If you want, please tell me at this stage now. Then I can do a few more examples and move forward. Is there any question? If not, I'll move into the new for the others topic where how do we calculate a future value of an annuity? Are you asking any questions? If not, please. Yeah, that's forward. Whenever you are not asking question or asking any clarification or making any comment, can you please mute your microphones? So ethics that you have to follow when you are in an online session. If you are not talking to the class, please mute your microphones. It's like when you are in the classroom physically, don't talk to each other or make other noises disturbing others. So please follow the same. Otherwise, it will disturb the other participant, which is not nice. So please mute your microphones when you are not talking to the class. Then whether you talk to someone else while the class is going on, then whether you pay the attention to the class or not, it is also something that you have to think. Then without paying attention, so now I have given enough time for you to ask any questions if these are not clear. Then next day, whenever we do other calculations where we use these equations, then don't tell or don't ask what is this. It's not nice, it's not fair for the people who has attended the class and concentrated. So pay attention now. If it is not clear, please ask now. Now let me know what is an annuity. We are going to discuss how to calculate the future value of an annuity. What is an annuity? Do you have any idea or not? If I go to this you can see this, my questionnaire and your responses. Only 32 has responded. I think there are about 50 participants. I don't know what happened to others, but however, through this I can see almost 70% are working for banks, and another 12%, 12.5% work for leasing companies. So 68, 12, it's more than 80%, and including insurance, so, and primary dealers. So almost everyone in the finance industry. So there are no students. That means he is not working, he or she is not working anywhere, just a student. There's no one such. So you should have some knowledge on these things. And not only that, you work in finance, and some are treasury, front office, middle office, back office, even operations. You might have some audit, risk. So you should know these things. And experience wise also, say only 12.5% has experience less than 1 year. Others are well experienced. And qualification wise, masters 25%, bachelor's 43%. Likewise, this is educational, but if we come to this one, IABF and DABF, see almost 28, 30% DABF, another 12.5% work towards that DABF, already got IABF. So you have some knowledge on this. So therefore, I expect you to answer these questions and see what you have already learned, whether you have learned it properly or whether you can remember those properly. If there's any gap, we have to fill that gap and move forward. So therefore, please respond to my questions. My question is, what is an annuity?
Annuity is a series of payment made at equal intervals.
Annuity is a
Series of payments made at equal intervals.
Made at equal intervals. Okay. Any other comments or definitions? Any other comments, definitions? say, she mentioned that it's a series of cash flows. Is it correct? It's not just not a single cash flow, and it is a series of cash flows. Correct? Are you all agree with that, or you have any other? Do you have any other comments? Is it clear? And it is a series of cash flows with equal intervals. What does it mean? Equal intervals. First, we'll start from that. What does it mean? Equal intervals.
Each period is equal. I mean,
Yes. Say if we say it's daily, there should be a daily, every day there should be a cash flow. If we say monthly, every month there should be a cash flow. Okay, every month. Say January. First to 31st. February. First to March. First to 31st. There's a cash flow in January 15th. Then in February, there's a cash flow in 10. In March 25th. Is it a monthly cash flow? Is it a monthly cash flow with equal periods or the interval equal interval?
no, sir.
No. Why?
The payment date should be equal. If it is 15th January, then it has to be 15th February.
15,
Every 15.
15, likewise. There should be a regular days. So that's the first thing. So if it is semi-annually, every 6 months on the appropriate date, likewise. So for simplicity, and in future also from now and onwards, I will use this notation. E equals 1. Then the next, I'm going to put the next one is T equals 1. T equals 0 means today, current. Right? And the future, whatever the period. If it is daily, T equals 1 means 1 day. If it is monthly, T equals 1 means 1 month. If it is quarterly, T equals 1 means after 1 quarter. Semi-annual after 6 months. So I'm not going to prefer whether it's monthly, daily, but I'm going to count it as the number of intervals. T equals 1, T equals 2, T equals 3, T equals 4, T equals 5, T equals 6. Likewise, how many cash flows?
6 cash flows.
6. We don't count today. We assume 6 cash flows at the end of the period. That's another assumption that we made, that we use even in this, the previous calculation, the equation that we use. Even in this, we assume cash flows occur at the end of the period, not at the beginning of the period. Here also same. Okay. Now, annuity is a series of cash flows occurring at equal time intervals. Is it correct? For simplicity, I put small numbers: 100, 75, 150, 125, 90. Again, now, series of cash flows occurring in regular or equal time frames. Is this an annuity?
No, sir.
No. Yes or no?
No.
No. Why?
Not the same amount.
Sorry?
Amount has to be same.
Amount has to be same. So you know that if I ask that question and you wrote that the equation, the definition that you gave to me, you won't get marks. But you think you are correct. What went wrong in your answer? You said series of cash flows occurring in same intervals of regular frequency. That part is correct. But whenever you say series of cash flows, you didn't mention that the amount should be the same. You forgot that fact. So that can't be the case. It should be clear on that. If it is 100, that has to be 100. This is an annuity. This one. This is a series of unequal cash flows. We have this one in our presentation as well. But here we are going to discuss this one. What would be the future value at this point? How do you calculate? So the first thing is definition of an annuity. So in the presentation, you can see there's a word one thing is it's a finite set of, the word is level sequential cash flows. Sequential here means with the regular time. So definitely I'm not going to ask this type of definitions, but you should know it when you try to solve other problems. And again, annuity we can define it into, or break it into two. The very first one is the ordinary annuity, where, which I have mentioned, the cash flow occurs at the end of the time period. So first cash flow occurs at the end of the first time period, not today. So that is we call ordinary annuity. So if you want to calculate the future value at the end of the annuity period, what would be the future value? You can use this equation, and again remember R and N are subject to that. N is the number of periods. In this example, N is 6. Whether it's annual, semi-annual, months, maybe. However, N is 6. But R is the R stated, that means annualized figure divided by the frequency. You have to adjust it. Not the annualized figure that you are going to use in this equation. What is A in this equation? It is the annuity, the amount of the cash. Is it clear? What are the terms in this? What are the terms in this equation? Is it clear? Any question? What is A? It's the annuity. R is the adjusted interest rate. N is the number of periods. Any question? Any questions? If not, I'll define the other type of annuity, which is annuity due, where the cash flow occurred at the beginning of the period, immediately now. So there will be a cash flow in an annuity due. In the annuity due, there will be a cash flow beginning here. And if there's only 6 cash flows at the end of 5th period, cash flow ends. So this is an annuity due. This is an ordinary annuity. Clear? Any questions? Any questions? Is it clear? What's the difference between annuity and ordinary annuity? The other one is perpetuity. What does it mean? In the annuity definition, I mentioned a word called finite series of cash flows. That means there is an end for the cash flow. In this example, only 6 cash flows. But there can be instances there is no end for the cash flow. It will go forever with the same frequency, same amount, but it will go forever. that type of so therefore there's no finite number of cash flows. It is infinite number of cash flows. We don't know where would be the end. That is called perpetuity. So perpetuity, a set of level, never ending sequential cash. Clear? Are you clear about these three type of cash flows? Ordinary annuity, annuity due, and perpetuity. Any questions? Any questions? So if you don't have any questions, we'll take a break here. After the break, we'll do a few examples how to calculate future value of all these three types of cash flows. Ordinary annuity, annuity due, and a perpetuity. Okay, if you have any questions, when we start again after the break, please ask questions or ask for any clarifications. We'll take a 15-minute break. Annuity. So we'll take this example, this ordinary annuity. There are 6 cash flows. Assume for both interest rate is 8%. And let's say this is semi-annual periods. What is the future value? So there are 6 cash flows. What is the equation? A first, we have to identify what are the terms. Don't get confused. In the presentation, it's written as this. Is it correct? In the presentation, the equation is given like this. Correct? But you can write it as A over R, the same thing, 1 plus R to the power n minus 1. Both are the same, there's no difference. What is A here? What is A in this example? What is A? What is R? What is N? We are discussing this ordinary annuity with interest rate 8% and semi-annual periods. What is A?
100.
100. pay it as cash flow, whatever the notation. In some instances, we put as flow divided by 1 plus R minus. Still same. Sure. When you see an example, you should be able to what are those? So A equals what is R?
8%.
8%. Is it correct?
You have to adjust it.
We have to adjust it. What does it mean?
8 divided by
It should be
8%.
4% because this is semi-annual cash flows. So therefore, we have to divide this 8% by 2 to get 4%. So this is wrong. It should be 4%. What is N? Sorry?
12.
12. Why?
Sorry, 6.
Why?
6 cash flows.
6.
The number of periods are 6.
Number of periods are 6. In this example, I have given the cash flow properly, so therefore only 6 cash flows in this 6. But if it is a wordy question and it says for a three-year period with semi-annual payments, then you should be able to multiply 3 into 2. Or if it says 6 years with semi-annual payments, then 6 into 2 into 12, something like that. So that's why, depending on the scenario, you should be able to identify these numbers, parameters. So now what you have to do, substitute these figures into the equation and get the answer. A is 100 divided by R 0.04 times 1 plus 0.04 to the power 6 minus what is the answer?
$663.29.
663.29.
9.
Is it correct? Does the others got same figure?
Yes, sir, it's correct.
So I believe it. I'm not going to work out. So if someone else got different answer, please let me know, then we can discuss. Is it clear how to do this? Any questions? Any questions?
So this means now we have 6 periods now, 100 rupees paid in each period. So the 663.29 means the annuity is paid future value, this 600, 100 into 6 plus the interest. No, the now so we have equal 600, 100 into 6, 600. No? So the 663.29 means, how do you say it, sir?
So this is the, you receive 100, not today, sorry. 6, another 1.5 years.
So sound is duplicated.
Up to 6 period.
Yeah.
Someone is unmuted. Otherwise there will be echo. So there are 6 cash flows. You collect them, and the applicable interest rate is 8%. What is the value as at the end of the period? At the end of the 6-year period, the value of these cash flows would be 663.29. As I mentioned, you cannot just add 100, and you say you get 600 because you receive 100 rupees in different time intervals. Or on the other hand, what does it mean? Let me put it into this. Say cash flow, time in cash flow. 1, 2, 3, 4, 5, 6. I hope you can see the Excel file. Is it?
No, sir.
Sorry. So this is timing. We have 6 cash flows. Then each one is 100 each. So what would be the future value of this cash flow at the end of 6 periods? How do you calculate what is the future value of this 100 at the end of so principal amount multiplied by 1 plus R, it is points. I put
0.04.
R here. 0.0 frequency 2, in the future value 100 divided by 1 R, but divided by this frequency to the power n. What is n? In this case 6. So I'll make it so this is the future value of the cash flow of the very first cash flow. Likewise, can you calculate future values of these? But in the second one, the future compounding should be only for 5 period. The next one only for 4 periods, 3 periods, 2 periods, and just one means is same as something wrong. Ah, sorry, we did a mistake here. What's the mistake? First cash flow, you earn interest for how many periods? Let me go
12
back.
periods.
Huh? No. That's the thing. This 100 rupees. Now you can see the board. This 100 rupees. Now first thing, tell me this future value as at which date? At the end of this, or at t equals 7. Where do we calculate this future? It is here, not here. So at the last point. Then this 100 you invest only for how many periods? The very first 100 rupees that you receive, you can invest only for 5 periods. And 1, 2, 3, 4, 5. From the beginning, from today there are 6 periods, but from the first cash flow there are only 5 time periods. Is it clear?
Yes.
So in the Excel file, we did that mistake. So let me present it again. So this should be only, that's the easy way for me. 6 minus 1, it will be 5. Is it correct? Yes. Then the last one should be 100 rupees. You get the 663,297.
So this is because the annuity is the ordinary annuity, right?
This is the ordinary annuity, yes. Now, did you get some sense about what is this number?
Yes.
Any other questions?
So I have a small question.
Yes.
Here, the interest is paid semi-annually now. So we adjusted the interest rate. Why don't we take the power as 6 into 2? There are 12 periods now, sir.
I haven't mentioned here 6 is the number of years. I didn't mention that. I just mentioned there are 6 cash flows, semi-annual
Okay,
cash flows. So in number of years, there are only 3. But
It's
there are
okay.
6 cash flows. If I say that this is not semi-annual, this is monthly, this is only 6 months.
Okay, sir.
Okay.
Okay, sir.
Anything else? Anything else? Is it clear?
Yes.
The concept and the equation. Is it clear? Any questions? Okay. If you don't have any questions, let me ask a question. Now the calculation for the ordinary annuity. Can you calculate what is the future value for this annuity due? I'm going to delete this. Same interest rate, same compounding, or same frequency of cash flows. What would be the future value of annuity due? Now you have this equation.
So we can't see the board properly.
Sorry,
We can't see the board properly, sir.
you can't see the board properly. Why? Not like that. Let me check. Okay. Now,
Okay, sir.
sorry. So this is the one we did completed. Ordinary annuity. This is the annuity due. What is the future value of this annuity due? How do you calculate it? May I ask a question? So is this the first time that you are doing this annuity calculations? Yes or no? Is this the first time that you do this annuity calculation? Yes or no? So I go back to this form. I can see there are so participants. Now there are 33 responses. So there are people with master's degrees and bachelor's degrees and DABF, maybe both having DABF and a master or DABF and a bachelor's degree. I guess mostly would be something related to finance. Am I correct? Am I correct? Can you please respond to me? And so, can you tell me if there's anyone who is listening to or doing this type of annuity calculation for the first time? Don't be shy. Nothing wrong in that. Is there anyone who is doing this calculation for the first time?
Yes, sir, for the first time.
For the first time. Others?
Yes, sir, this is first time.
Yes, sir. This is my first time.
What I mentioned, it would be better because those who are learning these things for the first time, they will pay attention and try to learn. But indeed, my advice or my warning is who have already, for the participant, those who have already done this type of calculations, because they may think, okay, I have done this in my master's or bachelor's or MBA or whatever, so I know this. But my advice is pay attention. What you learn there may definitely it's correct, but the application, I don't think you might have gone through what is behind that. You might say, okay, annuity is this frequent level cash flows, series of level cash flows, subsequent cash flows, and this is the equation for the future value. This is future value. Have you ever, no need to reply to me, but think, have you ever thought, okay, this is future value as of one date, whether it's at the end of this or even after a one period beyond that. Have you ever discussed that? Have you ever thought of it? So may not be the case. So that's why I'm trying to give you what is the real calculation, what or the real meaning of what we may see the same thing in different angles and maybe one step further down, digging little bit more into the concept. So the same thing. Now you know how to calculate the future value of a ordinary annuity. My question is, how do you calculate the future value of a annuity due? If you are clear about this, you should be able to answer this. Can you think about a way to do this? Can you break this annuity into two parts? I'm trying to help you. Think about it. Break this into two parts and try to apply this equation to one of that and something else that we already learned to the other part. What would happen? Okay, tell me, can we use this equation as it is to calculate the future value of this annuity due? Can we use it as it is?
No.
No. Why? That's the other thing. Even in the paper, I'm talking about that, not how to answer the paper, because that's your final intention, though my final intention is different. My final intention is to give you more knowledge on this. With that, you should be able to go through the exam. I'm not trying to help or aiming you to get through the exam. That would be the outcome ultimately, but that comes through the knowledge that you acquire. So my target is to transfer knowledge as much as possible to you. So in my lot of questions, as I did now, I asked whether you can use this equation and to calculate the future value of an annuity due. Can we use it as it is? The answer came as no. I won't stop there. Definitely I'll ask why or explain your answer. So be ready for it. Why, what are the reasons that you cannot use this equation to as it is to calculate the future value of an annuity due?
Because the cash flow flows from the beginning of the period. The period should be changed for the each cash flows.
Yes. So now in the annuity due, ordinary annuity, so we are here. We start the cash flow at the end of first period. But in the annuity due, first cash flow we receive or we pay today itself, and the ending period can be different from the end if we keep the same number of cash flows. So there's a timing mismatch. So how can we adjust it?
Sir, can't we take that few ordinary annuity answer divided by 1 plus 0.08 to calculate the present value?
We are not calculating the present value. That's one thing. We are calculating the future. But I think you are referring not to calculate the present value. Now only I got one mention. Calculate this future value and discount it for a 1 year back.
Yes.
That is, there are few ways that you can do it. this calculation. That's one. The other way is go back to the basic and calculate future value of each and every cash flow, as I did in the previous example for the ordinary annuity. You can do that, but it takes time if the cash flow is or the number of cash flows is very high. What else you can do? You can think this as a what? Forget about the first cash flow. The remaining cash flows, you are here now at time equals 0. What is this? What is this cash flow? This set of cash flows, there are 5 cash flows, 100 each in every 6 months. What is it? What do you call this? All set.
An ordinary cash flow.
This is an ordinary annuity. Then you can calculate the future value of this ordinary annuity as at this date. Correct? You can use this equation to calculate the future value of this ordinary annuity at the end of the year. But you are missing one part. What is it? The future value of this. How do you do that? This is just a single cash flow. You can calculate the future value of this cash flow at this date, and at that figure to the answer that you get here. Is it correct? Is it clear? Is it clear what I told you? There are 6 cash flows, equal payments with equal intervals, starting from today itself. So we first drop the today's cash flow and take the rest. We can consider it as an ordinary annuity. Then calculate the future value of that ordinary annuity, and then take the cash flow which is received today at time 0 and calculate the future value of that, and add that future value figure to the future value of the ordinary annuity. Then you get the future value of the annuity due. Got it? Is it clear? Is it clear? Now tell me, what is the future value of these cash flows? Ordinary annuity. What is A? What is R? What is N? For this equation, what is A? What is R? What is N? What is A? What is the size of the cash flow?
100.
100. There's no. What is R? What is the interest rate?
0.04.
0.04%. What is N?
5.
5.
5. There are 5 cash flows. Now you can substitute these figures. 100 over 0.04, 1 plus 0.04 to the power 5 minus to get 1 answer.
541.63.
541.63.
41.63.
So let's think, or let's assume correct. Then what you have to do? Calculate the present value of this cash flow. Calculate the present value, sorry, future value of this cash flow. What it is? Future value of cash flow 1. The equation you know, present value into 1 plus r to the power n. What is the present value? It is 100. What is r? What is r there in that? What is r?
Point 0.04.
0.04. What is n?
N6.
6. You are here. How many periods into the future? N is 6. Is it correct? Or any other answers? How many periods? 6-month periods from here. 1, 2, 3, 4, 5. There are only 5 6-month periods. The same. So n equals 5. You get that figure, then and these two figures together, that will give you the future value of the annuity due. What's the answer here?
So, and we take it up to T6.
No.
Now in the previous case also, like we took this N as 5, and
Yes.
for this also
That's for the whole. In previous example, when we use this equation, we took N as 6, not 5. When we calculate the future value of each individual cash flows only, we consider for the first one only 5 years, because we receive cash here and there are only 5 years. This is the end. In the ordinary annuity, this is the end, starting from here. So there are only 5 time periods. Is it clear? In the previous example, to get that 663 something, when we
yes,
use
in the same example,
when we use this equation to calculate the annuity or the future value of annuity, what is the end that we use? 5 or 6. There we use 6, not 5. But when we try to calculate the future value of individual cash flows, for the first cash flow, N is 5. The last cash flow, N is 0, because we calculate the future value as at this date, not at the end of the 7th period. Here, everything will be calculated as at the end of 5th period, starting from today. Is it clear? Any question? So that's good. If you have any question, please ask question, try to clarify, because these are the very basics, fundamentals that we may use in the future.
so in these two examples, like ordinary annuity and annuity due, both the answers are same. Now we have to add these two answers together, right? Then it's 663.29.
What answer here?
12166. 121.66.
0.66. Then when you add, it comes at
63.29.
63.25. Is it the same? Is it the same as the previous answer?
Yes.
Something.
So my question is, in this example, now we calculated two answers, no, 541 and 121. So for the 541 also we took R as N as 5. For the second section also we took N as 5. Is it right, sir?
Okay. Forget about this. If I ask you, shall I read it? I will figure out. You invest 100 rupees today for 5 years at R equals 0.0. Oh, sorry, R equals 8%. What is the future value? What is the future value here? Is 1, 2, 3, 4, 5 equals 0. This is 100. Future value you calculate as that. Correct? Is it correct? Then future value equals PV times 1 plus R to the power n. What is n? What is R? We'll assume this semi-annual story. What is what is
PV is 100.
sorry?
PV is 100. R is 0.08
PV is plus
plus
100. There's a noise. PV concept. Is it correct? Then n is n.
N is 10.
What is what is n? What is n in this example?
N should be 10.
00, 50, anything.
10, sir.
Three years. What is n now?
6.
6. How do you count it? 6. End of the first year. End of the second year. Can you repeat?
Yes, we can't hear you properly.
But yes, the noise coming from someone. Please mute when you are speaking. Okay, now can you hear me, please?
Yes, sir.
Yes. So you invest 100 rupees today for 3 years, semi-annual compound. How many periods that you count? Start from year to year, 1 period, 2 periods, 3 periods, 4 periods, 5 periods, 6 periods. Correct? That's why you use 6. Then you apply 1 plus 0.04 to the power 6, whatever the answer, you get it. Is it correct? Is it correct? Don't worry about the final figure. No need to do that. Is this correct? That this timing?
Yes, sir.
Yes. So now you are clear about this concept. Okay. Any question on this? No. Then may I go back to the our I'm not going to write the ordinary annuity here, but the annuity due. There's 100 cash flow here. 3, 4, 5, 6. Forget about these 5 cash flows. You want to calculate the future value of these cash flow as of this date. How many time periods?
5.
Sorry? What is it? What is N?
5.
5. Then what we did earlier, FP equals PV 1 plus R the power N is correct. Is it correct? That is 121 something you got. That is correct. When we calculate the future value of this considering as an ordinary annuity, that is also correct. But then we calculate the future value of the whole annuity as of this date. That's the problem. Since this is an annuity due, we should have calculated future value as of this date. Because we receive the cash flow beginning, but we assume and the end as this part. That is that we should have done. Instead, what we did, we calculated it here. Then it's almost like calculating present value one step of future value from here. That's the mistake we did. So we should calculate at the end of that period what is the future value of that annuity due. Otherwise, there's no difference between ordinary annuity starting from this and ordinary annuity starting from this equals equal. That is what we did. So Is it clear? We considered the end date incorrectly. We considered the end date as t equals 5, whereas it should be t equals c in both ordinary annuity and the annuity due. To consider the second one as an annuity due, otherwise it will like almost like a ordinary annuity. So work it out. See what are the answers you get. You can do it as I mentioned, go back to the basic. Calculate future value of individual cash flows and calculate using the annuity equation. Annuity, I'm sorry, you can't see that. Future value of individual cash flows. Second one, use annuity equation plus future value of first cash flow. Use both methods and see whether you get the same answers. But only the key here is when you calculate future value or the present value, you should know or be clear on as of which date that you are going to do the calculation. Even in the future value of individual cash flow, like here, you can calculate the future value up to here or up to here or up to here. Depending on that, your answers vary. Especially in a cash set of cash flows, whether it's at the end of the or receiving the last cash flow or after one time after that. That you have to be clear as of which date that you are going to calculate the future value. So with that in your mind, please do this again by yourself, and next week let me know what are your answers and any difficulties that you find out. You come across any difficulties you come across. Is it clear? Or you want me to do this now? That is also possible. Is it clear? Hello. Can you hear me?
Yes, sir.
Okay. So is it clear what I asked you to do? Clear or not? Please respond.
Yes, no. In this case, you mean to say that to calculate the
You
annuity due, we can
Yes.
We can take the ordinary annuity calculation plus the future value of the first cash flow.
First cash flow. But remember that time end. It should be here at the t equals 6. Not here. Because that differentiate the ordinary and annuity due is there. So end is fixed. We have to calculate the future value as of this date, not as of this date. But timing of cash flows are different. Switch each other. Let me put that into Excel rather than rewriting it again and again.
And so annuity and the annuity due is higher than the ordinary annuity anyway.
I didn't
And annuity due figure is higher than the ordinary annuity.
Yes. Why? Why? Why is that happening? Okay. So say you receive 100 rupees today, or you receive 100 rupees after 1 year's time, which will give you the highest future value. Did you get that? Oh, sorry.
Yes, sir.
Ordinary, you can see the Excel, no?
Yes, sir.
Future value as of this date. What is the future value? That you can use the annuity equation. The first to answer the question, annuity due future value is higher than the annuity due ordinary. Sorry, annuity ordinary annuity. Yes, the reason is, forget about these numbers. Say this one at the end of the first year, which gives you the highest figure. You have received this at the beginning, and you are going to receive the second cash flow as well. And there's a time value of my future value of this comes to here, say 104. So this should become 204. Whereas ordinary annuity is 100. So that effect will be there in the future as well. Is it clear? Is it clear? The value of money is high when you receive that early. If it get delays, you won't earn any interest income or something on that. So future value will be low. Is it clear that why the ordinary and why the ordinary annuity future value is less than the annuity due? Because you get cash flow at the beginning, then you earn the interest for that as well. If you receive, if you pay early, then you incur a cost on that as well. So calculate the future value of both cash flows as of this date. That's what I'm asking you to do. Is it clear?
Yes, sir.
Okay. Then you can do it in different ways. Try all these different avenues and see whether you get the same answer. Anything else? Unequal cash flows. Is that okay if I move into this unequal cash flows? We have another 10 minutes, or shall we stop here? But if we can finish this, then next week we can start present value, isn't it? Shall we quickly finish this one as well? What do you think? Okay, yes, I think we can finish this. This is nothing special. Oh, no, there's no equation. Why? Unequal cash flows. You don't know the amounts. Indeed, at the very beginning when we discussed about annuity, I showed you a different cash flows at different times. But then how do you calculate the future value of these cash flows? Say if I do it here, say there are 5 cash flows including today. This timing is very important. Remember, say there's a cash flow 100 today. This is 100. Then 150 here. 75 here. 110 here. 125 here. No cash flow here. But if you want to calculate the future value of these cash flows as of this date, 1, 2, 3, 4, 5. How do you do this? Say interest rate is, for simplicity, take it as 10%. How do you do this? What is the way? Only way that you can do this? What is the only way that you can calculate the future value of this unequal cash flow? There is no shortcut, or there's no equation. What can you do?
calculate the future value for each and every cash flow individually.
Exactly. What you have to do, calculate future value of each and every cash flow and then add them together. Now the question is, okay, this one, to calculate the future value up to this. Interest rate is 10%, that's given now. Then how many periods? What is N? That's the key.
5.
5. Correct. 1, 2, 3, 4, 5. For the second one, 150, what is N?
It's 4.
It's 4. Likewise, this is 3. Then this one, 2. This one, 1. So this 125, you have to calculate future value only for a 1 year into the future. 110, which is received at the end of third period, only for 2 years forward. So likewise, calculate the future value of each and every cash flow and add them together. Then you will get the future value of this unequal cash flow. For this, there's no other way of doing this. Is it clear? This is not a difficult thing. Again, we go back to our basic equation. Future value equals present value times 1 plus R. Again, remember that R has to be adjusted accordingly, and to the power N, number of terms, whether it's semi-annual, annual, irrespective of that. Once you adjust that interest rate to the relevant period, what we have to worry about the number of periods. So use this equation, apply for each and every cash flow, calculate the set of future values and add them together. Then you will get the final answer. Any question? From next week next week, we are going to do the reverse calculation. If you know the future cash flows, what would be the present value coming back? Now what we did today, we move forward from today into the future. In the next set of slides, we are moving back from future to today. So basically discounting. We are going to discount. So if you know something about discounting and things, better you refresh your knowledge. If not, don't worry, those who have not discussed these things, we'll explain from the beginning. So any question? So there's a homework, do it. And this equation, remember, this R, you can take it out from this bracket without changing FP over, sorry, A over R and the rest remains same. So time to time I may use either one, but don't get confused. Sometimes instead of A, I might write as CF for the cash flow, something like that. Whatever the notation, what you have to remember the shape of the equation and what are the terms. Even I write it as X over Y times 1 plus z to the power p minus 1, something like this. You should know what is x, what is y, what is z, what is p. Likewise, but I don't do that. There's a general few notations that we generally use. I'll follow those. I'm not going to use strange notations. But however, what I'm going to trying to highlight, you should know what are the meaning of each notation here. You should know that and how to apply this. So annuity due, work out and see whether you can get the answer, and try the. So someone said that you can use the ordinary annuity and discount it. See whether it's also working. You might see if you do that, you get a lower answer than the ordinary annuity. So whether it's possible or not, think about as well. So when you think about it, think about the relationship between the answers. So that sense we should have. So if we increase or move one more year forward, what would happen to the future value? It should go up. If you get an answer that lesser than the previous one, then something wrong. Say you calculate future value for 4-year period and the same cash flow future value for 5-year period, and 5th year future value is lesser than the 4-year future values, that is something wrong. So you should have that sense. Say same cash flows, you use 2 different interest rates to calculate the future value for the same end date. Then with the higher interest, you should get higher future value. If you get lower future value with high interest, something wrong. Then you have to go back and see what is the mistake that you have done. So yes, when you do the calculations, you definitely, even myself, I sometimes say at the very first example when I could use the ordinary annuity future value using individual cash flows, even I did a mistake. That can happen. But the thing is, you should be able to identify that something went wrong. Better if you can do it very first time, but when you don't do these things regularly, you may not remember equations likewise. But looking at the final answer, you should have some sense to identify whether this is a probable answer, correct answer or not. So with that, we'll stop here. If you have any questions, please ask now. We can spend few more minutes on that, answering questions if you have any. Any questions? Any questions? Or any clarifications you need? If you don't have any questions, we'll stop here. Please do the question that in your hand, and we'll discuss that next week. See whether you got the answers correctly or there's a comment. The thing is, I mentioned that last week as well. Don't put comments. I may not see these are coming, so I will miss. So whenever you have a question, please interrupt me and ask or make that comment. Don't worry. Kindly instruct officials to put class video recording at least on Monday in every week to see it again. I can ask them, but I'm not sure whether it's possible because during the weekends there are a lot of classes happening, so they have to do some editing and post. It will take some time for them to do that. So depending on that availability or feasibility, they will post it sooner it's available. Anything else?